Love at the University of Michigan, and we're here to start our virtual tour of the NEWtrient Recovery Facility here at U of M on the Ann Arbor campus in the G.G. Brown building. Why don't you come with me and I'll show you what we've got. So we're entering the Department of Civil and Environmental Engineering. Come on this way. We've got a urine separating toilet in the women's bathroom and a waterless urinal in the men's bathroom. Let's go. And so they're right here together with signage to tell people what's going on, and they can learn more about the circular nutrient economy. Let's go on inside. In one bathroom, we have a source separating divided bowl toilet. Urine is collected in the front, and all other waste plus most of the flush water is collected in the back. Only the urine goes to our processing room. We provide citric acid a few times a day to help keep the lines clear from solid particles that can form in the pipes. In the other bathroom, we have a waterless urinal. This unit also receives a periodic pulse of citric acid to keep the pipe that conveys the urine clear. And so now we're downstairs one level from the bathrooms that I showed you, where we have the waterless urinal and the source separating toilet. And down here, right over here is our processing room. And you see that we're surrounded by offices with graduate students. There's a classroom right there. And so our goal with this was to demonstrate what we could do in the building. And we've had this system since 2018 with really no complaints, no major complaints, and so we've been able to process in the building safely and as good neighbors. So if you look at our room here, we collect from the urinal and the source separating toilet here coming off the sewer. The residual, if it doesn't come down the pipes, which we can shut off, it goes into the sewer. We do have access to the sewer from here for waste disposal, so that's helpful. And then we take that urine, it goes into a master tank. At first we pasteurize using the Brightwater Tools pasteurizer. Then that pasteurized liquid comes back into a tank. And then we do the freeze concentrator. So this is a single stage Brightwater Tools freeze concentrator. And then our final product goes into the third tank. We also have citric acid down here where we pump up to the waterless urinal and source separating toilet to prevent precipitation in the lines between collection and this room. And everything is on an online system with sensors and data acquisition, all accessible to us and the folks at Brightwater Tools using our computer, so we can be communicating with them. They can see what's going on. They can do some controls as well on the freeze concentrator.
All right. Hi, my name is Jordan Landis. I am a current PhD student in the Nancy Love Research Group. And so we have just taken our licensed liquid fertilizer product, and now what we're going to do is we're going to process it further down into a struvite product and as well as a liquid product. But I can show you what the process is like inside. This is our lab space for the NEWtrient group.
Hey everybody, I'm Joe Liebeck, fourth year PhD candidate in the Love group, and I'm going to show you what we do with our product after pasteurization and concentration. So we wheel our liquid concentrated fertilizer into this fume hood here to prevent any odors. We're able to pump directly from our containers into a reactor here on this side of the hood. This reactor is where we do our struvite precipitation process. We add a magnesium chloride salt and we mix it all together and allow that struvite precipitation to occur. So our solid liquid slurry enters our sock filter here, our solid separator, and what we can do from there is we can pump the liquids out from the bottom into another tank, our nitrogen-rich aqueous fertilizer here, and then we can also take the solids out from our sock filter, and then we end up with a nice powdery struvite phosphorus-rich product. And you can see how much we're able to make from our concentrated urine that we get. Then once we have our solid fertilizer, that's ready to be applied on the fields. Once we have our liquid fertilizer, nitrogen-rich, what we can do is also run it through our GAC, granulated activated carbon filter. And what that can do for us is remove different things like xenobiotics, pharmaceuticals. It can remove things like PFAS to help us get a really clean product to be able to be applied on the fields. Once it leaves the GAC filter, then it is ready to be applied on the fields. So there's a lot of other research that we're doing on our urine-derived fertilizer products. If I show you in one of our other labs over here. So you saw our nice aqueous nitrogen-rich fertilizer product. What we're trying to develop is a nitrogen-rich solid-state fertilizer product as well. So in the lab, we're recreating the freeze concentrator system using a chiller, and we're pumping CO2 into our urine because the urine has a high ammonia concentration, and so it can absorb a lot of CO2. And so we have a little column reactor set up where we can pump CO2 into our concentrated urine, a bunch of sensors to monitor the system. And once that solution gets really saturated with CO2, an ammonium bicarbonate product can get precipitated out. So we're trying to do research on a variety of different ways to make UDFs and a variety of different applications from aqueous to solid state fertilizers.
And one thing that we're working on in our lab group is we're trying to pelletize our struvites so that it's easier for horticulturists or farmers to apply to their land or their agriculture. And one part we're trying to work on this is to make a controlled release fertilizer where we use, instead of fossil fuel derived polymers, we use biopolymers to help these fertilizers diffuse out at a controlled rate over time so that we can prolong the emission of our fertilizer and our nutrients.
Our team emphasizes conducting field trials with stakeholders to advance learning, sharing, and improving our urine processing steps and fertilizer products. For 6 years, we have been collaborating with the University of Michigan's Nichols Arboretum staff on a program we call P for the Peonies. Nichols Arb maintains North America's largest cultivar of peony plants, and our team conducts research with 120 plants, half of which receive a phosphorus and potassium-rich urine-derived fertilizer in the early spring when sprouts are 12 to 24 inches. We then return in early to mid-June to speak with visitors to the garden during peak blooming week about the value of circular nutrient cycles and alternative approaches to fertilizer production. Sometimes we offer free samples of struvite from our nutrient recovery facility. We're collaborating with university groundskeepers to test the use of UDF for turf grass applications. We are providing the fertilizer for a U.S. Department of Agriculture funded project that's evaluating the use of nitrogen-rich urine-derived fertilizer for a regenerative nutrient management study at the Kellogg Biological Station in Michigan. Here, we're evaluating crop performance with urine-derived fertilizer compared to other natural products and practices that recycle nutrients. Our team has long been focused on advancing urine recycling beyond just technology innovation. We've explored ways to remove barriers to innovation in urine recycling by developing new codes, standards, and licenses. In 2024, we applied for and received a license from the Michigan Department of Agriculture and Rural Development to create urine-derived fertilizer in our nutrient recovery facility and apply it to the field trials previously mentioned. We also advanced a plumbing code for urine diversion systems that's on its way to being included in the U.S. International Plumbing Code Appendix. This provides an opportunities for developers, builders, and fixture manufacturers by opening up commercial markets for urine recycling in the United States. Through our emphasis on technology development, demonstration, stakeholder engagement, and codes and licenses, our team is working really hard to establish creative and, in some cases, new pathways that we believe will open the door for broader deployment of nutrient circularity through urine recycling. So at Michigan, we like to say,
we're number one.